my earlier session, we have discussed about inventory, what is the importance of inventory, what are the objective of keeping the inventory, and what are the various factors which affect the inventory control. In the present session, which is a part A, in earlier session also we have discussed about the inventory control techniques, but there is a difference in my session. I have taken your whole journey from your study material only. So, if you study your material first and then you come to my session, or you first attend my session, then read the study material, in both way you are going to gain knowledge on inventory control and stores management. Again, I am repeating about the inventory. Inventory is simply a stock of physical assets having some economic value, which can be in the form of material. Inventory is also known as an idle resource as long as it is not utilized. In some books it is written that inventory is a stock which is to be used in the future. Certainly, this definition is also correct. Inventory may be regarded as those goods which are procured, stored and used for day-to-day functioning of the organization. This can be in the form of physical resource such as raw materials, semi-finished goods or finished products which are ready for the delivery to the consumer. In centuries ago, not now, in several centuries ago, inventory were viewed as a measure of wealth and power of a country or kingdom. A businessman's or a country's wealth or power were assessed in terms of quintals of wheat, heads of cattle, grams of gold stored in the store houses of the merchant, like that. The management of such inventories was not an easy affair. In recent past, inventories were also viewed as a measure of business failure, as they are locked capital. Businessmen therefore, today have started to put large emphasis on the liquidity of assets as an inventory, and large turnover has been the result. That means, they keep the small inventory, but they order several times. Now, what is inventory control? Inventory are viewed as a potential risk. Earlier, we are keeping the huge inventory and there was no risk, because we keep the inventory as a safety measure, but now it is keeping the large inventory is a potential risk. Therefore, due to fast development, due to change in the production life, due to changes in the product life cycle or expectation of the consumer is also changing. So, we do not want to keep a large quantity of quality control or inventory control. The present concept of inventory has been necessitated the use of scientific techniques in the management of inventories, which is known as inventory control. Therefore, inventory control is a technique of maintaining stock items at desired level. In other words, Inventory control is the means by which material of the correct quantity is made available as and when it is required with due regard to economy in the storage cost, ordering cost, setup cost, manufacturing cost, purchase cost and the working capital. So, the learning objective after this session, you should be able to develop some deterministic inventory model. You should be able to describe the use of inventory models in the practical situation. You will be able to explain single items as well as multi-item inventory, and you will be able to answer why large inventories are regarded as an indication that business is not well run. Now, we come to the inventory model. Inventory model determines what and how much inventory to carry and when to order. Inventory models help us to determine how much to order at any time and when to order this quantity to minimize the total cost. Inventory models, basically there are 4 steps, or in say the methodology for modeling inventory is based on the 4 steps. The first step is examine the inventories carefully, listing characteristics, assumption concerning them, then develop the total amount or total annual relevant cost equation in the narrative way. I have given total annual relevant cost is equal to cost of item plus procurement cost, carrying cost. In the carrying cost, there are 2 elements, cycle stock and safety stock. Then we also consider the stock out cost, that is cost or the sales back order cost. Third one stage is transform the annual cost equation model equation from narrative into the actual figure. And the fourth one is optimize the cost equation by finding the optimum for how much to order quantity, when to order, that is reorder point, and the total relevant cost. Inventory model can be classified as either deterministic when the variables are known with certainty, or stochastic model or probabilistic model when the variables are not known, or the probabilistic. In this session, we will discuss the deterministic inventory models. In deterministic inventory model, we first discuss the parameters. The first one is your economic order quantity. The concept of EOQ applies to an item which are replenished periodically in lots covering the several periods need. EOQ concept is applicable under the following conditions. Please remember and pay attention to each assumption. The first is that item is replenished in lots or batches either by purchasing or by manufacturing. Second, the consumption of item is uniform. That is means we are taking deterministic model and it is continuous. The model is described under the following condition. These are basically nothing but the assumption. Planning period is 1 year, demand is deterministic and indicated by the parameter D units per year. Cost of purchase or purchase of 1 unit is C. Cost of ordering or the procurement cost or replenishment cost is CO. For manufacturing, it is known as setup cost. Friends, we are discussing EOQ model, and under EOQ model, I am giving you the fifth assumption, that is the cost of holding cost is C subscript H per unit per year, expressed either in terms of cost per unit per period or in terms of percentage charge of the purchase units. Shortage cost, mostly it is a back order cost, that is CS per unit per year. Lead time is L expressed in units of time, cycle of period of replenish is T, and order size is Q. Now, we will come to the different situation. In this situation, it is required instantaneous supply and we are not allowing any shortage. So, the stock out condition will be vanished. With all these assumptions, a graph of inventory against time will be regular, that is the sawtooth pattern. This is a sawtooth model. You just see this figure, it looks like the teeth of the saw which is used for cutting either iron or the wood. We are not allowing the shortage cost. It implies that shortage cost is prohibitive or it is a very large or infinite. Since everything is known and regular, there is no need of cushion or the safety stock. So, inventory will run all together just as next cost is received. Under this EOQ model, we have a minimum quantity we will keep as a safety stock, maximum level, that is minimum level plus economic order quantity, reorder point or reorder level, that is minimum level plus consumption during the lead time. Since safety stock is not required in this case, we will set safety stock as 0, therefore, minimum level is also 0 and the maximum inventory is our order size or the lot size. The average inventory per cycle is 0.5 maximum level and the minimum level. Now, how this figure 0.5 comes? That is, we take the average. If maximum is 50, minimum is 0, then 50 divided by 2 or 50 multiplied by 0.5, that is 2.25, where cycles of intermittent pattern in which the inventory vary from maximum to minimum and then back to maximum when the order come back. The maximum inventory is Q, the average inventory per cycle is therefore 1 by 2, Q plus 0, that is Q by 2. Since average inventory during the one cycle period is Q by 2, the average inventory during 1 year is also Q by 2. Average inventory is independent of time. We will first find the what is the total cost. Total cost or the total relevant cost is equal to annual purchase cost. In short, we say PC plus annual ordering cost, OC, then annual carrying cost. Now, we were discussing about the annual purchase cost. We will take the price per unit into multiplied by quantity purchased per year. How you will calculate the ordering cost? The cost of ordering per order and the number of order per year. How you will calculate the annual carrying cost? The cost of carrying 1 unit and the average number of unit which is to be carried. Number of orders per year, that is annual demand divided by the order, that is D by Q. Therefore, earlier equation we can write CD cost of 1 unit, D cost of demand, C into D. Now, ordering cost, D by Q is the number of order, CO is the ordering cost, Q by 2 is the average inventory, CH is the holding cost. So, this equation will give you the total relevant cost. Under this economic order quantity model or optimal order size is that quantity which minimizes the total cost, and you will appreciate that the total cost is the sum of fixed cost and the variable cost. Here, what is fixed cost? fixed cost is the purchased cost, that the cost of one item multiplied by demand. It is independent of order. Whether we are giving 2 order, whether we are giving 50 order, this will remain same. Since fixed does not play any role, so we will remove this. So, in our total cost will be dependent on the holding cost or the ordering cost. So, we will differentiate it with respect to quantity, and then we will set into 0. Then annual ordering cost will be equal to the annual carrying cost. That means, our economic order point will be that point at which annual ordering cost is equal to annual carrying cost. If you just focus your attention on this graph, you will find a straight line coming from the origin, that is the annual carrying cost. That means, if you are increasing the number of order, your carrying cost will increase, but your annual ordering cost will decrease. So, the total cost curve, you will see, we will get a minimum at place where the annual carrying cost is equal to annual ordering cost. Under the EOQ model, which is given in the earlier, which I have said to you, and we have also provided a figure, we will examine that the total cost depend only on the fixed cost and the variable. Total cost curve has the lowest value at the intersection of two curve, which is known as ordering curve and the carrying cost curve. At the intersection point, two costs are equal, that is annual ordering cost is equal to annual carrying cost. That gives you the point for economic order quantity. If you drop the line on x axis, you will find the economic order quantity. From this earlier equation which I have discussed, we can say economic order quantity is the under root of 2 times ordering cost multiplied by demand divided by holding cost. You can also find out the cycle period, that how many times you can give or repeat the inventory or EOQ order. It is economic order quantity divided by demand, that is 2CO divided by CH, that is holding cost multiplied by ordering cost. Under root of that will give you the cycle period. Total number of orders, that is D divided by economic order quantity. Again, it is a under root of, since it is a D, we can find out how you put the equation which we have earlier shown you. This is the economic order quantity. If you place here, you will find the cycle period as well as you will find the number of orders per year. Total annual cost will be the purchase cost plus holding cost, which we have given in the equation here. What is the consumption during lead time? That is lead times in years multiplied by demand rate per year. Therefore, minimum level, if it is 0, maximum level is Q. Therefore, reorder level will be L multiplied by D, lead time multiplied by demand. We will give you one example. One construction company uses rupees 20,000 worth of an item during a year. The ordering cost was estimated as rupees 50 per order and carrying cost are 2.5% of average inventory value. Then how you will find the optimal order size, number of orders per year and the time period per order and the total cost. What is our hand? We have a demand of rupees 20,000, we have a ordering cost as rupees 50, we have a holding cost as 12.5% of average inventory. So, we will keep all the quantity in our equation and we will give as a economic order quantity as 4,000 rupees. Remember, we have a two types of problems. In one type of problem, demand is given in terms of rupees. In another type of problem, demand is given in terms of quantity. Now, what is the time period? It is under root of that coming as 73. Similarly, number of orders will be opposite of or reciprocal of time period, that will be the 5. You can also find out the total, that is variable cost, which is coming as if you put in the earlier equation, this is equation total inventory cost, total annual cost, it should be under root, then if you just see it, you will get as rupees 500. Another example we can take, an item is used at a uniform rate of 50,000 unit per year, no shortage cost is allowed and the delivery is at infinite rate. The ordering, receiving and hauling cost is rupees 15 per order, while inspection cost is 12 per order interest, rupees 0.056 and deterioration cost and obsolescence cost 0.04 respectively per year for each item held is inventory, plus rupees 0.02 per year per unit based on the maximum number of inventory units in the inventory. Now, our objective is to find out the economic order quantity, and if the lead time is 20 days, what will be the reorder level. Again, if you just see the numerical, P is 13 plus 12, that is rupees 25 per order. Similarly, holding cost, there are several costs is involved, that is 0.056 plus 0.04, it is coming 0.06. Similarly, storage cost is also based on the maximum, that is 0.0 per unit per year. So, we will see how you will calculate the storage cost, because if you are able to calculate these cost, the numerical will become very easy. So, what is demand? 50,000 per unit per year, total variable cost or the TC, again it will be under root of this. We will give economic order quantity as under root of 2 times 25 into 50,000 into or multiplied by 0.1, that is our holding cost, and our answer will be 5,000 per unit. Since 20 days is the lead time and our 50,000 is in year. So, we will convert 20 divided by 365 into years multiplied by 50,000 and reorder level will be 2,740 or 2,740 units. So, in this session, what we have learned? We have learned what is inventory, how inventory is controlled. Two most important question you should remember in your mind, that how much and when to order. We have discussed one inventory model, that is EOQ model, which is also a deterministic model. Then with the help of two examples, we have determined economic order quantity, time period and number of orders and the reorder level. I hope that this my session will, you must have enjoyed this session, you have gained certain knowledge in my session. Thank you.